All right. Okay. So here we have this triangle here, X, Y, Z. All right. And they tell us that X to Y is A and Y to B. Sorry, Y to Z is B. All right. Express the following vectors in terms of A and B. Now, when I say express the following vectors in terms of A and B, it means the answers. Your answers must have what? A and B. And we want what? X to Z. All right. So X to Z, but first we have to write our vector what? Equation. How do we go from X to Z? So this is from X to Z. So obviously it's going to be X to what? X to Y and Y to Z. All right. Are we clear? So X to Z is from X to Y and Y to Z. All right. But this is not in terms of common A and common B. All right. So what is X to Y? X to Y is just common A. And Y to Z is just B. All right. And that's the answer. All right. Any questions?
That was easy.
Yeah.
Difficult to figure out.
Yeah. Yeah, really not. So boy, compared to what we're doing, yeah, that's pretty simple, right? You know. All right. Then no. M to Y. M to Y. Oh, M is a midpoint of what? X to Z. So we have M there. All right. M is a midpoint. All right. So if M is a midpoint of X to Z, we can write some statements. Therefore, X to M must be what? A half of what? X to Z. Is that correct?
Yes, sir.
Come on, X to M would be a half of X to Z. So we'll just write that down. So we want to go from M to Y. So this is M, right? All right, and we have Y down here. So all right, so we can, oh, by the way, X to M is a half of XZ, and also MZ is also what? A half of XZ. Correct? Yeah, man. So both these statements are what? Are true. All right, now, ladies and gentlemen, how do we go from M and ending at what? Y? We can go two routes, correct? We can go from where? Somebody, I need a volunteer. M to Y.
You could go opposite.
And that would be M to what? M to X?
M to X, and then you have
X to Y.
X to Y.
Yes. And what's the other route? The other way?
MZ.
M to Z and Z to
ZY.
Y. All right. I think going M to Z and Z to Y is probably easier mathematically. And I'll show you why. So let's try M to Z, Z to Y. So we write our vector equation. M to I is M to Z and Z or Z to Y. All right. Now, what is MZ though? MZ is what?
A half.
A half
Half
of XZ.
XZ.
Right. So very good. So MZ is a half of XZ. Now, ladies and gentlemen, you know, when you're going to examine, you don't have to be so comprehensive like sir, you know. You understand? Remember, I'm teaching, so I have to present the information in a clear manner so that you can understand. All right, because you have to say, boy, sir, like I write this, and I say, sir, I have to do all them something up, so we could write A plus B. Yes, you could. All right. But you know, as a teacher, I have to write it in a manner presentable to you. You follow? And then Z to Y. Now, what is X0? Didn't we just work it a while ago? So XZ is actually A plus B. So a half XZ is actually a half of what? A and B, or A plus B, sorry. Everybody see that? M to Z, remember, you know, M to Z is a half of XZ. But what is XZ or X to Z? X to Z is A plus B. So therefore, a half of XZ is a half of A and B plus Z to Y. What is Z to Y? Z to Y would be what? Negative B, because Y to Z was B, so it's inverse vector. So Z to Y is minus B, so it's plus minus B. All right, everybody following so far? Any questions? All right, so then now, oh boy, I don't have enough space, you know. Let me see if I can squeeze it on here. So we're going to use the distributive property. All right, a half times A would be what class? Would be a half A. And a half times B would be what? A half B. All right, and a positive and a negative will give us one symbol, which is negative, and we write back to B. All right, are we good? And any questions? All right, so then now we're going to simplify this expression, because these two terms, the B and the B, can be what? Can be simplified. And we don't have to do a lot of maths, you know, to do this. All right, now what number is beside B? That is not written.
1.
1. All right. So what I'm gonna do? Well, I mean, class. I mean, let's look at this. What is a half? A half from 1.
A half.
A half. If I spin it around, what will be 1 from a half?
0.5.
No man, I'm saying, what if I spin around? What if I have a half here?
Oh, negative a half.
All right, we have negative a half or negative 0.5. So look at here, look at this. Isn't this 1 from a half? So 1 from a half is negative a half. But we have the b there, so it will be negative a half what? B. All right, so answer. So well, we're just gonna write by the half a. So we have a half a. And 1 from a half is negative a half b. Sorry about the space here. Hold on, I have space, man. I have space. So it's going to be a half a subtract a half b. And ladies and gentlemen, this is our answer. Any questions? All right. Let me give you about 2 or 3 minutes to write it off. All right. Can I move on? All right. So this thing is being recorded. So if you I know some of you guys came a bit late. I'm gonna see if I can upload this thing on YouTube. It's been a while since I've uploaded anything on YouTube because you know. All right. So can I move on? Nobody's responding.
Yes, sir.
All right. All right, so we're gonna move on to something a little more interesting. Let's look at question number number 5. All right, so I don't know if you're gonna write it off or what. All right, so it has part 1 and part 2 and part 3, but we will do them part by part, yeah. All right, so you have to bear with me because my screen is very small and there's a lot of working out, and sometimes one part is connected to another part, and I may have to erase some parts. Unless I put everything on a Word, a Word document. Hold on. Let me see. All right. So I don't know if you're going to take this off. So let's take this off. This question. As you can see, it's a parallelogram. And there's something called a parallelogram law. I don't know if you guys remember that. You have a triangular law and a parallelogram law. It's about 2 or 3 more minutes. Sometimes, even when you have the worksheet, sometimes when you write out the question for yourself, you know, it cannot feel more like you're part of the question more when you write it down for yourself. All right, let us start with this question. And what you notice, we've moved away from position vectors and P to O and O to. So this is actually a different aspect of vectors, right? All right, so let us read the question, let us analyze the question. But before we start, they say that this diagram is a what? What is it? A parallelogram.
Parallelogram.
So basically, P to Q is U. So if P to Q is represented by a common U, S to R is also what? U. P to S is represented by common V. Likewise, Q to R is also what? V. Comprende?
Sí.
See? What you see? All right. All right. So, all right. So PQRS is a parallelogram, and P to Q is represented by a common U, and P to S is represented by a common V. Now, is it this part here, so? This part here, so let me explain it to you. All right. Now, when it says, well, it says that M, you have QS, right? You have QS, and there's a point on QS called what? M. All right. And they give us the ratio. All right. Now, let me tell you what this do not mean first before I tell you what it means. Let me tell you something. You know what I said? Let me tell you what it don't mean. You see this here, so? This doesn't mean that 1 QM is equal to 2 MS. It does not mean that. Okay? That is wrong. Do you follow me? All right. So let me tell you what it actually means. All right? Because this is ratio with dimensions, not ratio with like ratio. It's ratio with dimension, with length. What this means, you see? It means 2QM, it takes 2 of these. It takes 2QM to make what? 1 MS. That's what it means. Or it takes 3 QM. It takes 3 QM to make 1 QS. Or you could reason it another way. You could say QM is a third of QS. So we notice the 2 is nowhere to be found in the reasoning, not true? So when it says QM to MS is now 1:2 ratio, it just means a what? 2 of this makes us what? 1 of that. All right, it's actually the other way around. Is that what the following? I want to say it again.
Go again, sir. Say it again, sir.
All right. Okay, so what I know? QM, Q to M, and M to S is in a what? 1:2 ratio. Now, how do you write that in terms of vectors? It means it takes 2 of this, 2 QM to make 1 MS, M to S. That's what it means. So you see this right here, so? Put 2 of this right over here, so? And you get M to what? S. Put 3 of them, it gives you what? All of QS. Or you could say QM, is just a third of the whole thing. All right? I hope that resonates in you. All right. So now that we understand what this means, let's carry on. First one, can I easy? You guys want to try that one? Somebody tell me what is Q to S. Who wants to know what Q to S is? Or tell me the vector equation first. Someone tell me the vector equation. Q going towards S.
Okay. So QS is it will be equal to a half. No, no. Let me just make it. So QS is equal to 1/3 of no. I'm confused.
All right. How would you go from Q to S? Which route do you take?
QM.
Right.
Oh,
Q. Well, no, you wouldn't go QM. You wouldn't go QM. You
QR,
right. Q to R,
R,
R to S.
R to S,
Or what? What's the
No.
other way?
QP,
Q to P and P to
P
S.
to S.
Yeah.
Ah,
It doesn't matter which way, you know. Let's go from Q to R and R to S. So Q S is from Q to R, and then from R to S. Now, what is Q to R? Because it's in terms of U and V.
V, V.
Very good, because PS is V, so therefore QR must be V. And why is that so, class?
Because PS is opposite to QR, and it's a parallel, because it's parallel.
Well, no, the latter part of what you say is correct, right? Because the diagram, because it is a what? It is a parallelogram. And a parallelogram is a pushed rectangle. So it's like, imagine you have a rectangle, right? And you glue down the base of the rectangle, and you give it a push to the right. The sides will slant to the right. And when you notice, you'll get something like this. So a rectangle, sorry, a parallelogram is a pushed rectangle. All right, and in a rectangle, opposite sides are equal. So Q to R is V. And what is R to S? What is this? What is R to S?
U.
Hmm?
U.
Also, are you?
Negative
Minus
U,
U.
sir.
Negative U. Remember saying, no, we're going from where? R to S. But P to Q, P going Q is U. So if you go the other way, it'll have to be what? Negative U. Remember, P to S is V. So we go from Q to R. It's going the same direction. That's why it was V. All right. Now P to Q is U going that way, but if you want to go the other way, it will be negative U, and that would have been the answer. Well, it's plus, right? But the plus and the minus will automatically be a minus. Any questions? All right. Let us look at part B now, which is what? Q to M. Now, where is Q? This is Q, right? We want to go from Q to M. But didn't we make an observation about Q to M, class? What did we say about Q to M?
Q to M is 1/3 of
One
QS.
third of what? Q to S.
QS.
Right. So Q to M is 1/3 of Q to S. But what is QS, class?
Tiga tisod na bababa ang label but choosy bigalabo.
V minus U.
All right. Well, I think someone needs to meet the mic. Okay. Right. Right. Yes, you're correct, boss. QS is what? V minus U. So this is going to be 1/3 V minus U. All right. And we can use the distributive property. And we'll get 1/3 V subtract 1/3 U. And those are the answers. So remember, is it this thing here now? Are you have to formulate it here? Right. So we can put this on a Word document. All right, any questions? May I move on?
You can move on.
All right. Okay, so I'm gonna move on. All right. So we looked at part 1, A and B. Let us look at part 2 now. Part 2 says that show that M to R, M to this R is equal to 1/3 U plus V.
It's plus 2v, not plus v.
Okay, yes, sorry about that. Yes, you are correct. All right. Okay, so let us look at M to R. So where's M? M the right there. So well, let me get a bigger diagram. All right, so we want to go from M to R. So it says to show that M to R, what is it, class? A third U plus 2V. A third.
MR will be equal to a third
U
M
plus 2V. All right. No, let us not focus on this here. Let us focus on how do we go from M to R.
Okay, so M to R, you have
We can go three different routes, not true?
you have MS SR.
Okay, M to S R. That kind of shorter, not true?
Yes,
Shorter
sir.
than
And
M to
easier
what?
to get to
Are we
the
gonna go from where? M to where? Q
Q.
and Q to R. All right.
But sir, remember, you know, it's that easier to go from M to S because M to S will be 2U.
All right.
And
All
then
right.
S to R will be the single U. And it will be positive because it's going up, which is in the same direction as the opposite side.
What is the M to S is?
2U. And then the S to the R will be the
Hold on it.
2U.
How you get that? How you get that? How you get MS to be 2U? Because the 2 is right here? No, sir. I'm gonna give it a 2. So what is QM? If M to S is 2U, then therefore QM is U, but it can't be U because P to Q, you know, look at P to Q. P to Q is longer than M QM, you know. So I'm saying? See, you can't reason it that way, yeah? Let me show you something. Going from M to S would be a bad idea. You know why? Because we don't know what MS is. Or we can actually work it out, but it's gonna take forever. Wouldn't it be better to go from M to Q? why is it better to go M to Q?
Because you already know what 2M is.
We know what QM is. So if I want to know what MQ, all I need is flip around this vector here, don't you? QM, and we get MQ. All right. All right. So let me just write down what MQ is. Now, Q to M. See, right? I would love to have a whiteboard now. Q to M is all of this, right? 1/3 V subtract 1/3 U. But if I just spin around this now and write M to Q, this 1/3 V will become negative. And this negative 1/3 U becomes what? Positive.
Yeah.
Everybody see that? Because I'm spinning around this letter here, QM to MQ. So everything in the answer will go negative or positive. All right, so let's go back to the main page. So it is more practical to go from M to Q and then Q to R. So M to Q no, sorry, it's M to R. Sorry. That's what I want to find. M to R is M to Q plus what? Q to R. Now, MQ, well, we know that QM what is QM again? 1/3 what?
1/3 minus 1. Hold on. It's 1/3 2S.
1/3 V minus 1/3 U.
All right. Well, so the karon by the one. You was it?
No, I'm home.
Okay. I'm not careful when talking, okay, you know. Probably a pass, I'm not even know. So, yeah, so QM is 1/3 V minus 1/3 U. So therefore, class, MQ is the inverse of QM, meaning that this 1/3 V becomes what? Minus what? 1/3 V. This minus 1/3 becomes what? Plus 1/3 U. All right, and this is MQ. And we're going to drop this down right here. So not sure because M to R is M to Q. So M to Q will be what? Negative 1/3. 1/3 V plus 1/3 U. So all of this, ladies and gentlemen, is M to Q. Then no plus what? Q to R, and that's easy. Q to R is just what? V. All right. Are we following? Any questions so far? But then no, we're going to group like terms, all right? All right, so what I'm gonna do, I'm gonna put this V with this 1/3 V. and put the 1/3 u to the right. All right. Now notice I purposely put the v first, then the u, because if you notice all the answers start with what? Well, this one is v and u. We can change up still. All right. Now we recognize that these two are what? Like terms. All right. So what number is beside the v, but you can't see this v here? What number is beside it?
1.
1. And since these are two like terms, what is 1/3 from 1 whole?
A quarter.
Notice I run by the man.
What? If you get
What?
if you have
1/3 from one
one,
unit, I count quarter, man.
how much again?
Must 2/3. What's 2/3 plus 1/3? Gives us a unit, not true?
Mm,
You see it? Let me tell you, quarter and 3/4 would add up to give you a unit, yeah? Oops. All right, so 1/3 from 1 unit will give us what? 2/3. So that's 2/3 v plus 1/3 u. Any questions? But how is this getting us closer to the answer? What the question says? Show that what? MR is what? 1/3 u plus 2v. All right. So if you notice, we have a 3 here and a 3 here, not true? So we can actually factorize out that 3. It's actually 1/3. All right. So I'm gonna go up here. So I'm gonna factorize out a third. So if I factorize out a third, what left back is 2v plus u. Or you could use the distributive the commutative identity to say, okay, same thing as u plus 2v. All right, so this is something as 1/3 u plus 2v. That's the answer. All right, and any questions? This is part 2, right?
yes, sir.
All right. Any questions? All right, so this is the final part here. All right, can I move on? All right, let me put this on a Word document. So part 1. So this is going to be part 2. Let me try it. All right, let's look at part 3 now. It says, what is it? T is the midpoint of what? P to Q. All right, P to Q. So T is right here. T is the midpoint of P to Q. All right, prove that R, M, and T are collinear. Collinear does mean that the points R, M, and T lie on a straight line. Okay? So how do we prove that 3 points lie on a straight line? I would explain to you, right? So T is the midpoint of P to Q. Are you guys following? I don't know, because nobody said Jesus. Our Lord Jesus. Or no, nobody is quiet. So it gets that you guys are understanding this really, really well. Or you just scam bother or just a boy, you know?
Yeah, bother.
As an idea.
Scam bother. Something like nobody said Jesus. I would not say Allah. Or Rasta.
So just having a headache. Long headache.
Yeah, you know something that nobody said Selassie before though. Jah. In the class I said Jah Selassie. All right. So this is part 3. Let me write down what it says. It says T is what? The midpoint
Of PQ.
right.
Prove that R, M, and T
Right.
are
Prove that.
collinear.
Thank you, sir. Prove that
R,
R,
M,
M, and
and
T
T
are
are collinear.
collinear. All right, so let me just write in T. So T is right here. So basically what they're saying, you know, if you're to connect these, you get a straight line. So they want us to prove that what? These 3 points are on the what? Are on the line. All right, that's what's happening. All right. No, yes, boy. Who we are going to do now? Or a cell phone. Everything is. Okay, I'm trying to draw a straight line here, but not at all. All right, that's the best straight line. The worst no. So that's T. Now, how do we prove that R, M, and T are on a straight line? You know what we need to do? We need to find RM. Find RM.
But we know I am already.
Eh?
We know I am already.
Yeah, follow man. Real talk. Yes, we know what RM is. That's good.
Okay. Eddie can shot in about kind of focus.
All right, so we need to find Rm, but that is already what? Given. We already found it, not true? And then what we need to do is to find out M to T. Notice the order. Notice the order. It says R to M, M to T. So R to M and M to T. You have to do it that way, okay? What do we know what MT is?
No.
No. So guess what? So the one I'm doing? The man said, all right, you need to find two things, but one of them we work with already. The other one, you have to work it out. So then this is what we need to find. All right. So class, what is the vector equation for M to T? How do we go from M? What's the easiest and more convenient way to go from M to T? It will be from what? M to what? Q and Q to what?
And T.
To T. Wouldn't that be the best route?
Yeah.
Yeah. You know why? Because we know what M to Q is, don't we? Yeah.
Yes.
Yeah, man. So the best route is M to Q and what? And Q to T. QT. Now, ladies and gentlemen, what is M to Q? Show us a work. M to Q, isn't M to Q this?
1/3 V minus
No, man.
1/3 U.
No, that's Q to M.
M to yes, sir.
M to Q.
Yeah, that's the
No, man.
Hold on.
Look
No,
what that.
wait. Oh, it's 1/3
No.
2V
No, boss.
plus
Q to
U.
M.
Yeah,
Q
but
Negative one
right.
third.
Negative
V.
1/3 V. They not see just someone see
so I'm gonna put down the negative for mine. Hold on.
We don't know.
We put down the negative. Come here, book.
Okay, so M to Q is negative 1/3 V plus 1/3 U. All right. So M to Q is negative 1/3
V plus 1/3 U.
V plus 1/3 U. All right, everybody following?
Yes.
All right. No, then no plus no what? Q to T. All right. So you want to know what I'm saying? T is the midpoint of P going Q. All right. Now remember that P to Q is U. P to Q is U. All right. That means well, hold on. It says T is the midpoint. So PT is a half of what? PQ. Everybody agree? P to T will be a half of P to Q. And T to Q would also be what? A half of what? P to Q. All right. So Clark, let me ask a question. If P to Q is U, therefore P to T must be what? A half U. All right. And T to Q must also be what? A half U. Correct? So what you know? We know that M to Q is this, right? But what is Q to T? Let me see who's thinking. What is Q to T? Hmm?
Negative.
You say it correct, man. It's going to be what? Negative what? A half U. Because remember saying no? T to Q is what? T to Q is what? A half U. T to Q is a half U. So Q to T must be negative a half U. So this is negative a half U. So then now let us simplify. So the U and the U will go together. So right here, so would be 1/3 U subtract a half U. Now, an easy way of doing this is to drop off the letter and just work with the what? The number. And when we finish, we just write back the letter. What's LCM here? 6. What's 3 into 6? 2. What's 2 ones? 2. What's 2 into 6?
3.
3. What's 3 ones?
3.
3. And it's going to be negative 1 over what? Over 6. Right. So all of this is negative 1/6 U. All right. So this is what MT is equal to, class. Any questions? All right. Now, what did I say? What are we trying to prove? We're trying to prove that R and M and T are what? Are collinear. All right. So what we do, we find RM, but we know what RM was, not true? And then we just found out what M to T is. All right. Well, let us write down what RM is. Or was. What RM was it? What is, somebody tell me what was RM?
A third V minus a third U.
You sure?
Hold on. No, a third bracket U plus 2V bracket. That was what?
RM was
But that was MR, and then I will flip it over and get a minus third.
Oh,
Minus a third. Yes.
so it's minus a third what?
Bracket U plus 2V bracket.
All right, hold on. Excuse me, that one. Well, let me see if we can.
Remember, you know, the question said, show that MR equal 1/3 open bracket U plus 2V close bracket.
Hold on. So
it's
MR, it's MR, right?
Yes.
So M to R
is equal to
1/3.
a third. Yeah. open bracket U plus 2V close bracket.
2V. All right.
Close
Very
bracket.
good. Which
So
which is
RM would
one
be
third. Hold on, which is
RM would be the negative.
1/3 U and 2/3 V. But what you're saying that we don't want MR. What do we want? We want RM.
Yes, we have flip it around and turn
Right.
to negative.
So RM now is negative 1/3 U subtract what? 2/3 V. Everybody see that? This is M to R. So R to M is this, right? So watch out now. Let's go down here. Now we want to compare RM and what? MT. That's what we're going to do, right? So RM. All right, you see what happened here? Is it because MT starts with V and end with U, but this one starts with what? U and V. Let's try to make it common here. So what I'm gonna do, because this start with V, I'm gonna write the one with the V first. So RM is minus 2/3 V subtract 1/3 U. What is that? Yeah, I just spin this around because in order for us to do a reasonable good comparison, let's compare the V with the V and the U with the U. All right. All right. Anybody lost? Anybody following me? Are you guys following? Why?
So far.
Why? I want somebody me attack. Novia, are you following? Oshin, Romario, Camille, Brittany, Anake?
Yes, sir.
Others? All right. All right. Or is it that because it's online, you have less distraction and you're concentrated? You know?
I prefer to be in class right now.
Yeah, because you can't sit down and say that someone said, me not understand. You said, you realize that, yes, me not understand too, you know?
No, sir, I'm confused.
All right, you're confused now?
Okay, I write over this and then I reach over this and then I come back down this and then I ground this. Yeah, confused.
So when you drive, man, when you drive, you have to drive like a bad driver, you know? So when you self-drive, man, no, what? No, I understand. Let me tell you, if you just walk in the class and you saw this, you probably faint. But I mean, if you're in the whole time, you know, and following through, you know, you would write it properly in your book, because the screen is limited. All over the place. I'm not expecting you to write it like so, you know. All right. Okay. All right, now, let us say we understand, right? We need to prove that R to M and M to T are on a straight line. So we wrote down what R to M is. Oh, by the way, well, we didn't know what RM was. We knew what m to r was, which is this, and we expand it to that, and we flip it around, and we get that. All right, and then because we want to compare the v with the v and the u, we kind of spin it around. All right, now how do we prove that rm and mt are are collinear? So what we need to do is, see, we need to prove that rm and mt are parallel. Yes, ladies and gentlemen, we need to prove that rm and mt are parallel. So to prove collinearity, all right, so I'm going to erase this. To prove that rm and t are collinear, what we need to do, we need to prove that r to m, the vector rm, is parallel. I'm using that symbol to what? To m to t. And how do we prove when something is parallel? Class, somebody tell me, how do you prove that something is parallel?
They must be opposite to each other and equal.
How you prove? We write in the notes, man. How you prove when two vectors are parallel? When both of them are traveling in the same what? Direction. And what? When one is what? When one vector is what? A scalar multiple of the other. Right. Like when you scale fish or something like that. No? Who's not talking? So one's a scalar. In other words, can I multiply rm by a number and get mt? Can I multiply mt by a number and get rm? So let us evaluate. What can I multiply? Let me get a little hint. What can I multiply mt by to get rm? I said, give me a number what I can multiply mt by to get rm. Look at it. So let me set it out for you. Give me a number. And you multiply by mt. You get what? Rm. Let's go back down. Talk to me, no, man. It's right there looking at you,
I will find in the LCM.
No, man. Give me one number when you multiply. Give me a number when you multiply by
Okay.
by this. You get no. You get this. What can I multiply? Huh? What can I multiply this by to get the one over here, so on the left hand side?
1.
You can't get 1, man. If you multiply by 1, you get by the same thing, and then the same thing over here, so.
Oh. Melande.
What is right here, sir, class? What is right here, sir?
2.
2. What is 2 times 1/3, class?
2/3.
So 2/3, man. You know, sir, this topic here, you know, sir, I just fractions. You realize I just be a fractions, man. This is not of good vectors, you know. All I'm doing is adding, subtracting, multiplying, fraction. All this topic is about is fractions. If I multiply 1/3 by 2, class, don't I get this on the left hand side? And if I multiply 2 times 1/6, class, what is 2 times 1/6?
2/6.
2/6. And when you reduce that, what do you get?
1/6.
No, boss. 1/3. And isn't this 1/3 over here, so? So what's the conclusion? If you multiply MT by 2, what do you get? RM. So that's the answer. So the answer is 2MT. So since 2MT is equal to RM, then what? R, M, and T are what? Collinear. All right? And that's it. Don't worry, man. I'm gonna upload this on YouTube and you can watch it from start to end, okay? It looks a bit confusing, you know. All right. Guys, you want to take a little 10-minute break?
Yes, sir. Come.
Eh? Because what?
Yes, sir. I'm cooking. So yes.
You
Okay.
cook? You serious? All
No,
right.
sir. I'm not. Yes, sir.
We
I'm
all
serious.
want, we want some, so make
You
sure
know, say,
make sure
you know, say,
cooking after
I don't
that.
understand. Only have math class and I cook no math class.
It's a calculation, you know, sir. How much
Eh?
time must put in the blender to the pot, how
So
much
hold
time
on,
must
when
blend
you
the
cook,
flour.
when you cook, you use vector. You know, so you use vectors when you cook though.
Measuring.
Just kidding. All right, guys, I want to take a little 5-minute break or 10-minute break. Okay, so it's 8:10, so we rejoin at 8. What 8 what 8:20? 8:20 8:20. All right. All right, guys. Okay, let's see if we can do another question and wrap up this thing here. I'm just gonna try to put I've been cutting and pasting this question. All right. So let me see if I can. I'm gonna send this question in WhatsApp. So mind you, it looks a bit really messed up. All right, let me see if I can. You guys are hearing me? Want to speak, please? No, you're not hearing me?
Can hear you.
Okay. All right, I'm gonna share my screen. I can find the document. Oh boy, where is it? All right. No, sir. I'm gonna give you this one to try now. Think you can start number 2? Write down number 2 and see if we can start it.
Sorry, me hardly hear you if you are talking. The chip in and out.
I'm chipping in and out. Is that true?
Sir, I can hear you well.
All right. It's probably your internet here. Yeah, so start number 2 for me and you know see how far you can reach with number 2. All right, guys. So I hope you've been processing information. And let me tell you, the more questions you do like this, the more manageable it becomes. All right. All right. So let us look at this question here. So a lot of information was given. All right, so let's get to it. So it says O to P is 3U. All right. Now, if you notice on the diagram, it says O to L is what? 2U, and L to P is just U. So they give you that information. All right. So we're processing the information. And they say that O to Q is V. O to Q is V. All right. Processing the information. Check this out now. Q is the midpoint. Q is the midpoint of O to R. Where is O to R? O to R. So that's Q. So what they're saying that Q is in the middle of what? O to R. All right. That means that O to Q must be a half of what? O to R. Am I correct? If Q is the middle of O to R, it must mean so what? O to Q must be a half of what? O to R. And Q to R must also be what? A half of what? O to R. All right, y'all agree?
Yes,
No?
sir.
Yeah, man. All
Yes,
right.
sir.
Yeah, man. Yeah, man. I need some more supporters. All right. All right. Let me ask a question. And tell me if I'm wrong. If O to Q is V, right? Check this out. If O to Q, all right. Hold on. What is this thing? Oh. If O to Q is V, right? And Q is half of O to R. What is Q to R? Somebody tell me.
V.
Have to be V. Because I'm saying Q in the middle, and then from O to Q is V. It's like saying you have a piece of strip of wire. And you tell a man, say, boy, say, from yes, the middle, and from right to right is 10 centimeters. And the right is the middle. Then if from here is 10 centimeters, then the other piece must be what? 10 centimeters. It's the same idea. So Q to R is V. All right, so you write it down. So we notice what Sir doing. Sir is extrapolating all information before he actually start answer the question. In other words, don't let the question rule you. You rule the question. You become the boss of the question. All right? Or don't be a slave to the question. So you pause and say, listen to me, man. I am in control of this. All right? Right. And some persons are very dominating in everything. So just dominate the question. All right. It also says that M is the midpoint of what? P to Q, so therefore M is in the middle. So clearly P to M is a half of PQ, and M to Q is a half of what? PQ. All right, and it also says that L is a point on O to P, right over here, such that O to L is 2/3 of O to P. All right, so basically what am I trying to say? This is 2/3 of O to P. This section here.
Sir, does that mean that L is 1/3?
Aye. Yeah, man, you get sober now. The rest piece, the other little piece here, L to P is 1/3 of what? OP. Very good, sir. All right, lots of information, that's all. All right, let's get to the question now. L to M. Where is L? This is L, and this is M. So I'm thinking probably the easiest route is to go from where? L to P
L to P
and P to M. All right. So L to M. From L to P.
Sir, quickly.
Yes.
Would that be equal to, would LM equal to 1/3 LP?
Would
No.
LM?
LP.
Yeah.
To find LM, would that mean that it would be equal to half to 1/3 LP plus PM? I don't know, just asking.
Hold on. The fan, I have a fan. It's so loud. Turn off it. All right, go again from boss. Sorry about that.
I was saying that LM, would LM equal to LP, which is equal to 1/3? The LP
What?
would be 1/3 LP plus PM.
1/3 of what?
I'm asking.
One. It's a 1/3, but 1/3 of what?
So I just wanted to know if LM would be equal to 1/3 LP.
All right. Okay. Yeah, man, you're correct. But you keep on saying 1/3, but it's 1/3 of what? OP. You just said that a while ago, you know. You just said that this was 2/3, not true? Of OP,
Because
right?
it's find LP. Because it's find LM. I was thinking that I maybe need to shorten it as LP is equal to 1/3. Just
No, it has to be 1/3 of something here.
okay, understand.
Yeah, it has to be one. But guess what? I'm not going to watch out. Them tell you what LP is, you know. Look here, you see it. Then I'm stress yourself. What is LP? You see it?
You?
Yeah, it's you.
Are you?
Yeah, man.
Okay.
So LP.
But just see.
Yeah, LP is you. As a matter of fact, I'm not gonna lie to you. We're not gonna use this. So it's LP plus PM. And LP is what? Is you. But what is PM, class? M is a half of P to Q. So PM is going to be a half of what? P to Q. But do we know what PQ is? No. That means a what? We're going to have to what? Find it, but it's not difficult.
PQ.
How do we go from P to Q? P to O.
P to M.
No, man.
And then
No.
backward.
Yeah, you want me now? You want?
No, M is the midpoint, so it couldn't be M for you.
me a second, guys. All right, sorry about that. All right, you want me now? Is it to go from P to Q? You wouldn't say P to M and M to Q, because guess what? No? A PM want to find, you know. You understand? If you want to find PM, you can't go ask yourself what is PM again. So you have to go to another route. So I'm saying, which is what?
Just really can figure say
Right,
which is actually
right,
B.
which is P to O, which is P to O and O to Q. What is PO, class? Mr. Who's smart in here? Mr. Who learn? What is PO?
1/3 U.
Mm.
No, 2/3 of U. That's all.
Oh man, look on the diagram. Look on the diagram here. Look on the number.
3U.
No, you almost get it.
Is it -3U?
Who said that? Marlin Malahuford? Who said that?
Yes, sir, it's me.
Malahuford. Right, so look, from O to P is what? 3U. Not sure, look at it. It's two. What is 2U plus U? 3U. So going that way is what? 3U. But going the other way going to be what? Negative what? 3U. Plus O to Q. What's O to Q? That's easy.
V.
Just V. So P to Q is all of this. But remember, we want to find PM, but PM is a half of what? PQ. So this is going to be U plus a half. Let me just write it up here. So a half PQ, therefore, is going to be a half of everything inside here. So not true. All right, and that's going to give us negative. Well, a half times -3 is -3 over 2U, and a half times V is a half V. All right, I'll tell a line, it's kind of rough enough. The first part roughy, man. And then now, well, we're just going to simplify this, not true? Because this is U and this is U. So just drop off the letters for simplicity. I'll just work with the number them. There's really fractions, and when you finish, just drop in the letter them. What's LCM there? 2. What's 1 into 2? 2. What's 2 ones? 2. What's 2 into 2? 1. What's 1 times 3? 3. What's 3 from 2? -1 or negative a half. So this is actually negative a half U plus a half V. And that's it. Now that's a rough question for our first part.
Hold on, sir. I'm moving too fast. Let's try write it. I may still never take it fully, you know.
Let me tell you, man, see these questions? These are essay type questions in mathematics. All right. I have to sit down sit down and just go through it, you know. I know so the more you go through one question, the less time it takes you, and you always learn something more. You ever notice? Study one question one time, gonna take you a long time. Go over it again one at a time. You go through it faster, and you learn something new. Go through it the next time. You go through it with ease, and then when you go through it ease, you probably can connect something with another topic or another question. And that's learning. It's very, you know.
Sir,
Yes.
the part of now you check, or you get the 1/1. The part of
How do I get the
1/1.
1/1?
Is it where you have the U minus?
Yeah, man. Yeah, it's right. It's this bracket I'm working out.
Oh, that's okay.
Yeah, just drop off the letters, man. Yeah.
Oh, that's right.
Let me see if I can put this document. All right, so that's the first part of the question, believe it or not. That was B. Okay, so B no is what? P to R. All right, so let's look at that. So looking at B no. All right, so we want to go from where? P, you know, so it's easy compared to this. My word. How do we go from P to R? There are two routes. P to O and O to R, or P to Q and Q to R. Which I think this is the easier route. P to O. All right. What is P to O? What is PO? We just did a while ago. Are you guys hearing me? Marlin just said a while ago.
-3.
Right, -3U. And what is O to R? Let me see who's not sleeping. What is O to R?
V.
No, man. O.
2.
My brother.
2V.
O to Q is V, you know. But remember, say this is V again. That's it. All right. So that was an easy one compared to LM. All right, everybody follow that?
Yeah.
Yes. All right, can I close this?
Yes, sir.
All right, let's look at the last part of this thing here now. And prove this collinear thing come back up again, not true? Prove that the points L, M, and R are collinear. So, so L to M to R. So class, guess what? No? We need to find LM. Do we have LM already?
Yes, sir.
Yeah, man. LM was the first thing, not true?
Yeah.
LM
Is minus 3
a half
U
U,
plus
right?
3.
So LM is minus a half U plus a half V. So since you know what LM is, what we need to find is what? MR.
Sure.
Yes.
A PR that is just a PR that is just hold on. Oh yeah, yes. Yes, I
All
know
right.
what I'm talking about. So my
Right.
kind of
Okay. So MR, guys, how do we go from M to R? The easiest route is M to Q, Q to R, not true? Come on, because otherwise you have to go so, and so. Not too much route, too much rigmarole with that. So I think the easiest route is just M to Q. And then what? Q to R. Well, we know that QR is what? V, not true? But what is MQ? Isn't MQ a half of PQ? That's what I got, class.
yes, sir.
And what is PQ? You're supposed to work that out, don't you? You're supposed to work at a half PQ already, man. A half PQ, see here? A half PQ is this, is
I have open bracket minus
is negative 3 over 2U plus a half V, not true?
Mm-hmm.
Yeah, man. See, we work it out. Sit up here, sir. This is a half PQ. So it's negative 3 over 2U. So it's negative 3 over 2U plus a half V. So that's half PQ or MQ. And then we have QR, which is just what? V. So we know that these are two common terms. So this is going to be negative 3 over 2U plus, well, isn't this a half and 1? And what's 1.5? 1.5 isn't that 3 over 2? All right. So this is 3 over 2 V. So MR, this is MR. So you know what I want to know? What are we asked to do? Prove that what? L, M, and R are collinear. No, this is LM over here. LM. And this is what? MR. So class, let me ask you a question. How do we prove that points are collinear? We need to prove that what? LM is what? Parallel. So this symbol means parallel to what? MR. Now, how do we prove something is parallel to one another? What do we need to prove? What do we need to know? We need to find out what?
A number that you can divide both of them.
Not well, no,
Divide
not
both.
necessarily. Well, yes. You could say it that way, or you could in a scalar what? A scalar factor. In other words, one way you can multiply or divide. You're correct, you know. It could be that, but it's easier to find out what you can multiply. So look at these two things from the class. Let me give you a hint. What can I multiply LM by to get MR? Look at it. Look at it. They're staring at you. What number can I multiply LM by to get MR?
2, sir.
I can't do, you know? Because let's test it.
Mr. 3.
3,
That,
sir.
it will have to be 3. Because 3 times this half here, so gives you 3/2. And 3 times a half, you 3/2. So that is it. So the answer would be, so since 3 LM, since 3 LM gives you an MR, then what? LM is parallel to MR. And because they are parallel, the points L, notes also answer the question, I mean, or what? Colon here. All right, and you can try, I think I have some more questions to do. But let me tell you, man, if you can try to get at this quickly as possible, you know, don't sit on it here. Yeah, man. That's hard work and dedication, man. Trust me. All right. That's it. I think on this worksheet we have about probably about 3 or 2 more questions to do. You can try those on your own, all right? All right. This is for Saturday workshop. Please take a scientific calculator. Yeah. We're gonna look at something called trigonometry. And trigonometry? Yes. And there are certain functions on a scientific that's not on a regular scientific calculator. I'm discouraging you from using your phones. I want you to get your own scientific calculator, you know. Yeah, man. Well, if you can't, you know, bring your phone, but not all phones can work here. There's some phones where don't actually there's a little issue. Or if you can borrow scientific. All right.
Yeah, the bang of them. Yeah.
Hmm?
Yeah.
No, man.
The
No.
smart bang of them.
Smart bang. Which one is smart bang? That's about.
You know, touch screen them and they can't go online with what when you put in things like turn away, you know, come out as it's supposed to. Yeah, smart
Oh, okay. All right. So, ladies and gentlemen, let me just encourage you to read over your notes. Trust me, it's not easy. The education business there, it's not easy. Not easy at all. Not, you know, easy when you think about university and college. Trust me, not easy. But anyway, still, it can be done. Not true, because many persons are graduating. Not true. All right. So, I'm hoping to see all of you guys on Saturday. I remember that it's a mixture class here, so I have students from the Saturday group, and I may also have students that I will even teach at Wilmots, because there's a day school that they might come. All right. So we'll be looking at geometry and trigonometry. I would have always sent you the 2 worksheets. Unfortunately, the ink toner in the printer copy are finished, and I am unable to copy in the papers. So if you can copy the papers yourself, get a copy for yourself, it'd be nice. But I mean, if you don't copy it, it's all right, because honestly, I'm not gonna lie to you, it's better when you draw your own diagram than if you write on something print already. I'm not gonna lie to you. And the diagrams are not so complicated. All right, so that is it for me.
Excuse me, sir.
Yes.
Is it 9 o'clock the class will be starting?
Yes, it's a whole day thing from 9 to 3, and Sunday will be, I'll do a couple hours on online Sunday. Yeah, I haven't decided that it wouldn't be a whole day on Sunday online, but more than likely it's gonna be in the afternoon or in the evening.
Sir, I wouldn't be able to make it for Saturday, so I'll probably have to join on Sunday.
Oh dear. You know, say everything make Sunday I just like one recap, you know.
I have to work on Saturday, and during the time you have classes, during that time I have my shift.
Okay. And nobody can work for you on that day?
No, they don't normally give us weekends off.
Oh my. Why? So you tell them young people who are going to school, you know?
Yeah, it's really hard.
Really rough. I mean, you have to work because